Everyone, so today we're going to be talking about isosceles and equilateral triangles, and actually I think I wrote 4, 5, but this is the 4, 4 video. Now, I know we've already reviewed what an isosceles and an equilateral triangle are, and we've actually gone over the theorems, but I wanted to review it. So an isosceles triangle, remember, is a triangle that has at least two congruent sides. At least two congruent sides. Okay, we call those legs. Now, remember, we want to be careful. These could be congruent, but the other sides could be congruent as well. Like those two could be congruent. And the equilateral triangle we know is a triangle with all three congruent sides, okay, which gives me three 60-degree angles. And remember, I want you jumping to it having three 60-degree angles versus just saying they're congruent. And I know that's going to help us in the future, okay? All right, so let's go back to those theorems. The isosceles triangle theorem and its converse. Now, let's just recall that if a theorem is true, if we prove something that it's true, and therefore its converse would also be true, so we could always write it as a biconditional statement. That means we can go backwards and forwards, and sometimes that can be challenging for us to think about. So the isosceles triangle theorem basically says that if you have an isosceles triangle with two congruent sides, then the angles opposite those sides are congruent. The angles opposite those sides are congruent. The converse would be that you have a triangle that has two congruent angles. If I have a triangle with two congruent angles, then the sides opposite those angles would be congruent. So I want you to think about that a little bit as we move ahead, because working backwards and forwards between these two can be really helpful. All right, so we've been practicing using those two theorems in class. So what I want you to do is I want you to try these four problems. I want you to press pause, try them, and let's review them when you come back. Okay, so you're back, and hopefully you saw it was an isosceles triangle, so therefore you marked your diagram with the base angles congruent, the angles opposite that. So x would be 46, and y would be 180 minus, 92, which would be 88 degrees. All right, this one, what I hope you saw again was that there were four actual congruent marks, meaning that all of these angles, 1, 2, 3, and 4, were equal. All right, so working a couple of different ways. We've got a linear pair right here, so that makes this angle 40, which 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 makes this angle 140. All right, and x we get from 40 plus 40 is 80, and so x would be 100. Now, I wonder how many of you actually said, oh, look at that. Alternate interior angles are actually congruent. Which means one more thing that you could actually gather from this picture, you could then say that these lines are parallel. So we never want to forget those things that we've already learned. We want to be able to apply them. All right, on this one, again, we had these four congruent marks, meaning all four are equal, which makes all of these angles equal to each other. So if this vertex angle is 75, I do 180 minus 75, which gives me 105. And then 105 divided by 2 is going to give me that x is 52.5. So hopefully you got 52.5. And if that's 52.5 and that's 52.5, then we can honestly then look at y and say that it's 75. Now again, what other things might be helpful to you? Well, I saw the 75 and the 75 and the 52 and the 52. They are alternate interior angles, which makes these lines parallel. All right, last one. Hopefully you noticed that I saw that equilateral triangle this time. It has two hash marks, so I quickly jumped to 60, 60, 60. I noticed the right angle right here telling me that these lines are actually perpendicular, which makes this 30. So that gave me x was 30. And then y would be 180 minus 60, which would have given me 120. Awesome job if you got those right. All right, so how can we go further with the isosceles triangle? Well, you have to remember in geometry that we've looked at all different types of ways we can create figures and put things together. So now I gave you a circle, and I told you that the measure of angle R, so this angle right here, is 22 degrees, okay? And it says find the measure of angle RXZ. Now remember, an angle is made up of two rays. So this RXZ cannot be this ray here and this arc. We call that an arc this way. So you are allowed to actually use that auxiliary line we talked about earlier this year. So I'm going to draw a line from X to Z. Once I've done that, I've created angle RXZ right here. Now, what you already do know about a circle is that all radii are congruent. All radii are congruent. So these two radiuses are congruent, which makes this an isosceles triangle. So all I'd have to do would be 180 minus 22, which is 158, and then 158 divided by 2, I think that's 79 degrees. And there you get the 79 degrees. All right, I actually want you to try this proof. But the one thing hopefully you noticed is that the proof says measure of angle 1 is congruent to measure of angle 3. We can't say that. We actually have to say angle 1 is congruent to angle 3. If we use measure, we use equals. So I want you to fix that. And I want you to try the proof, and we're going to go over it tomorrow in class. Make sure you got it. Okay, you're using the isosceles triangle theorem. All right, then I want you to go through equilateral triangles are, each angle of an equilateral triangle is, and a new way to find the area of an equilateral triangle. Now, we went over that really quickly. See if you remember it, because we're going to talk about that formula tomorrow. All right, so let's try this last one. I love this problem. It is another equilateral triangle, so I immediately jump to the 60 degrees. I see the 90, that's going to give me that n is 30. I see a right triangle right here. If this is 30, this then becomes 60 degrees. All right, why don't you try these last two, because they're kind of review problems. Bring them to class tomorrow, and we will go from there. Have a great night, guys.